Welcome back. In the first part, we implemented a rough Pygame structure and we added our first class here, which is the person class. Every person got an X and a Y location, and we have this method here to show this person in our two-dimensional game screen. Now let me just quickly change this here. Instead of using the color definitions dictionary, I'm now using the colors dictionary and say that at first every person is healthy. But of course, they will not always be healthy. So how do we make this dependent on whether the person is currently healthy, infected, or whatever? Well, the person has to have a certain state in which they find themselves in. So let's create a new property here, which I'll call self.state. And at first, we'll set this to healthy, but we'll then have functions and methods in the future to alter that state of the person. Now down here, I can simply say self.state. So let's run this code. We again have two people here. They're still white because they're healthy. And if we were to change this to say immune and run our code, they are now blue. And if we were to change this to say infected, they should now be red. And indeed they are. So this appears to be working quite nicely. To make our lives a little bit easier in the future, I'm going to be implementing one or two additional key controls down here. The first one will be the escape key to exit out of the window. So I will not always have to navigate to the top right corner of the game screen to exit out of the animation. Now right now it just says track user interaction. It does not distinguish between mouse clicks and keyboard presses. So we now specifically have to tell Pygame, watch out for keyboard presses. So we'll just say user presses keys on keyboard. And now we'll just say if event.type is equal to pygame.keyDown in uppercase letters. Now we can address individual keys on the keyboard. And the first one will be escape key to close, just to close the animation. And in Pygame, the escape key is referred to as event.key. Yes, that's always the same. Is equal to pygame and then capital K underscore escape. And well, if the user presses the escape key, I'll just set animating is equal to false. Now we can run our code, and now instead of going up here and clicking up here, I'm going to go back here into the middle of the screen, but instead I'll just hit escape and the window closes, the animation is over, our code has finished, the execution is finished, and this is working. And I'll also, the other key controls, I'll add them later on when there's actually more happening, because right now we only have two people. So let's set this back to healthy. We don't want to be starting with everybody already being infected. The next thing we'll do though is we'll introduce movement to our persons class. Right now it's perfectly static, people cannot move around. So let's define a new class, which I'll call move. And you know what, since the show method is so short, I'll just put the move method after this here. In terms of parameters, let's just say there's a certain speed at which people move. Now you'll have to play around with this. I found that 0.01 is a somewhat reasonable value. It sort of depends on the frames per second and the number of people that you have on the screen and how large the screen is, whether or not this is a good value. So you might have to play around with this a little. It's not attached to like actual units in terms of meters or something like that, whether or not it makes for a good animation. Anyway, let's go down here. Now, how do we make for good movement? Well, I think the simplest approach would be to have something like self.x plus equal and then random.uniform, say minus speed and plus speed. Now we don't have to have the plus sign here, so I'll simply type speed. Now we'll do the same with y. So what we're doing here is we're saying change the x location by a random value between minus speed and plus speed. And we'll just add that to x, and then we've changed the x location. We'll do the same with y, and then, well, our two people should have moved. So let's go down here, and before we're displaying the two people, let's say person1.move and person2.move. And let's see whether that works. We get an error and it says person 1 is not defined. So I must have just accidentally deleted this part. So person 1 is equal to person, and person 2 is equal to person. Now I run this, and you can see these two dots up here. I'm going to close this, set this value to 0.1 instead of 0.01. Run this once more. Now you can see that they are jittering around a little. It's not much, so we might have to increase this even further, even though I just said that 0.01 was such a good value. Let's run this again. And now you can see how they're moving around. Unfortunately, it's not really movement in the sense of a smooth development. It's really just, jumping back and forth, and we don't really want that. And to make for good movement in Pygame, the approach that I always like to take is, let's just think about this a bit more like how a particle would move in a physics simulation. So instead of only having x and y, that is the location, the location vector, so to speak, of where this person is in space, but let's also have a velocity vector. And yeah, throughout I'm going to be using the terms velocity and speed interchangeably, even though they're really not. But let's just add these two additional things here, and I'll just be calling them dx and dy. We'll set these to 0, so we'll set dx is equal to 0, and dy is equal to 0. And now down here, with the movement, we'll say self.x plus equal self.dx. And dx is really just a change in the x location, and dy is the change in the y location. And then we'll use this randomness part down here to update the change in the x and y location. Now self.dy plus equal whatever this is. Oh, no, only this part here. Okay, let's run this. Now we can see that the particles, or the two people, are moving a lot more smoothly, and it looks a lot better. Notice, however, that at some point they will leave the screen because, their positions can take any number and they can grow infinitely large or infinitely small, and they'll just wander off and, we'll lose them. So what we'll have to do next is we'll have to make sure that once they hit the boundary that they are thrown back into the animation so that they just bounce off the edge of the screen. So let's take care of that. Okay, I'll introduce some comments here. Adjust position vector. If you don't know what a vector is, just don't bother too much with it. You don't really have to know. And down here, I'll just say adjust velocity vector. Now here, well, this will be the part where we'll say avoid going out of bounds. Okay? How do we do that? Well, whenever self.x is greater or equal than the width, that's when we have a problem. That's when they are going over the right-hand side margin of our window. Okay? Well, in that case, we'll set self.x equal to width, and I think I'm going to set it to -1, so that's thrown back inside, and then we'll reverse the velocity vector in that direction. So what we'll do is we'll just times equal that with -1, which means the person will now go back in the opposite direction. Bear in mind, though, only in the x direction, so only in the horizontal direction. So if a person was coming in from the top left, moving down, they will now be going in the bottom left. They will not be going straight back up because that wouldn't be natural movement. So we're only changing the x direction here. And then we'll do the same with y. So if the vertical position is greater than height, in that case, we'll throw the person back inside. So we'll just set this to height -1, and then we'll update dy by multiplying it with -1. So let's see what that looks like. There's another error here. That is maybe, I forgot to put if before the if statement. And now we have our particle here, and it bounces right back off here. So see this? Oh, what is that? Well, of course they can still escape to the top and to the left because we only took care of the right-hand side margin and the bottom margin. So let's close out of this, and let's take care of the other two margins. So if self.x is less or equal to 0, well, in that case, we'll set self.x is equal to 1, and self.dx times equal minus 1. And then the same thing with y. Self.y is equal to, if self.y is less or equal to 0, well, in that case, self.y is equal to 1, and self.dy times equal minus 1. Okay, that's a lot of code for the movement function, but I think it's pretty intuitive to understand what's going on here. So let's save this and run this, and now these two dots should never go out of bounds again because they're always thrown right back in. So let's check this. Yep, bouncing right back in. And now down here, it's doing a double bounce because it was right in the corner. Now it's just moving around, sort of like, do you remember these old screensavers for the DVD recorders where you have that DVD logo bouncing back off? So it's sort of the same thing that's happening right here, okay? Very nice. We implemented movement. But instead of just having two people, person 1 and person 2, let's make that a list. So I'm just going to call that people is equal to, and we'll just use a neat list comprehension here. So P for P in person for I in range. Let's just make this 10 people. And now down here, we'll say for P in people, move them, and then show them. Let's run this and look at this. We got 10 people moving all over the screen, but they can never escape, and they're just moving around. And yeah, this is a healthy and happy population. Nobody's infected. And yeah, nothing will happen here other than them moving around. So let's introduce patient 0 to this. So let's just go into this. People 0. We'll just select the first person in this list here. And since, well, everybody's generated randomly, it's, it doesn't really matter which person we choose. But I think it's kind of nice that, because of zero-based indexing in Python, this is the 0 person and it's patient 0. How, that's just nice. So people 0.state, let's set this to infected. Now, if we run this, we now have this person here, which is our patient 0, but we haven't implemented any sort of code such that this person could infect other people. So right now they're just moving around and they can meet other people, but these other people will not be infected. That's the next thing that we have to take care of. We'll go back up here into the person class, and we'll add another method. And this method, I'm just going to call it get infected. So people now have the chance to get infected. And well, what does getting infected look like? Well, there isn't really a lot happening other than self.state is set to infected. Now, okay, this is not infected. This is interesting. I just had an R in there and it still worked. No, it didn't. I added that later on. Okay, I was a bit confused there why this would have worked. Anyway, it does not. It has to be infected, otherwise the code will. If I run this now, yeah, there's the person. Okay, great. Anyway, we now have to make use of this function. And the easiest way to infect other people is the following. And this is a very inefficient solution here, so we'll have to fix that in the next video. But for now, it's really just to get the ball rolling to make sure that our animation is progressing. But later on, we'll see the problem with this. So let's just say infect other people. So we'll just loop through every person in people. It's the same thing that we have up here. Now we'll say if p.state is equal to infected. Well, in that case, we'll say for let's just say for other in people. So we're now looping through everybody once more. If other.state is healthy, well, that is when infections can actually occur. So the first person has to be infected and the other person has to be healthy. And now we'll compute the distance between these two people, because if we think about this, just because somebody somewhere in the world has a certain disease, that doesn't mean that you automatically contract it as well. So you would expect that you would have to be close to this person, and depending on the bacteria or virus, you would have to touch the other person, or you would have to be in the same room and breathe the air that they've been exhaling. Whatever it is, it doesn't matter. There's this notion of you have to be close to the disease in order to catch it. So what we'll do here is we'll compute the distance between these two people. And the Euclidean distance between two people, it's really just a super easy equation. It's defined as the square root between difference of the two x locations, so p dot x and other dot x, and we have to square that, and then add to that the same thing with the y location. So we'll just take this, copy this over, p dot y and other dot y, and now this operator here, this power operator and the square root function, they are only available in the math module. So what we have to do, we have to go back up here and we have to import this module. Import math. And then we can take square roots and square numbers. Okay, so now that we have computed the distance between these two people, let's say if dist is less than, let's make this 20, so the disease should spread pretty easily. If dist is less than 20, then we'll say other.state is now, we don't have to set this, we have a new method for this. Remember, we just created this getInfected method, so we can just say other.getInfected. And let's run this and see what happens. So people are moving around, and let's see whether at any point another dot that comes close would catch the disease. Okay, right now nothing appears to be happening. Maybe people are just getting lucky and they are not coming in close enough, or there's an error in our code. Nope, there's not. This person just crossed with this other person here, so they crossed ways and now they got infected, and now it's already 3, it's 4. This is working. The pandemic is now starting to unfold, and yeah, we can really see this. Very nice. It's only really just a matter of seconds until everybody in this little tiny window here is infected. Also, given the speed of how fast they are moving. So let's exit out of this, and let's see whether we could run this animation here with more than 10 people. Let's go for 100. Now this is obviously no problem, or apparently no problem. Everything is running perfectly fine. There is a lot of infectious activity going on, and yes, this is working. So let's not try 100, but 1000. Now notice how the dots are not moving as quickly anymore, but the whole thing is still working. Okay, so we can still see this. There's infections going on, the disease is spreading, but something has changed, and that's just the speed at which people are going. And to understand this, we have to look at what's called the frame rate. So when Pygame is running, it's just continuously updating the screen, and it's called different frames. So each update is its own frame. And now let's introduce a little counter at the top left corner that tracks how often we are updating the screen. Unfortunately, this is a bit of a pain to code this. It's a bit of a pain to code this in Pygame or in Python. Maybe there's a smarter way, and I just haven't figured this out. But yeah, I do it by using the clock object in Python. You know what? Let's do this in the Pygame loop. So I'll create the clock. So this is just the counter that keeps track of how long the animation has been going, and we can do that by using pygame.time.clock. And then I'll specify a font in which we'll be displaying the frames per second counter at the top of the screen. So I'll be creating this font. I'll say pygame.font.font with an uppercase F, and then I just select a font that's available on my system. So I'll just say free sans bold.ttf with a font size of 32. Now down here where we update the screen, I'll just say update the screen and the clock. Okay, so here I'll say clock.tick. This means, well, the clock just ticked. So I think that's pretty nice. But other than that, it's sort of a pain, and this is now just 5 lines of code that I think most of you will really just copy from what I'm typing here. You don't have to worry about this. It's really just to display the frame rate in the top left corner of the screen. So I'll create a new variable that I call clock string, and this is the string of math floor. So, this is just rounding down from clock.get frames per second. Yep, that's it. And now we'll create a text object from this. So I'll just say font.render. And here I'll be using the clock string. Then I'll set this to true here. Don't worry about this too much. I'll now say color, definitions. I'm going to be using bold blue to separate it from all the white dots at first. And then I'll set another color. I'll be going for the background color. So this is now the background of the text box, and if it's the same as the background, it will just be like as if it was transparent. And then we'll turn this into a rectangle that can be bulleted to the screen. So we'll say text box is equal to text.getRectangle, simply get rect. And then we'll specify a location. We'll say this is top left, and we'll indent this slightly. And we'll have to specify a tuple here with the X indent and the Y indent, and I'll be using 10 pixels each here. And now we can say screen.bullet and then text in our text box. Okay, let's go back up here, set this to 10 people, and let's run this, and there we have it. The animation is running. And up here, you can see it's a pretty large number, somewhere in the 5, 6, 700s, and the animation is running extremely smoothly, and we have a very high frames per second count. So let's exit out of this and run this with 100 people. Now it's still super high, it's still 400 or 500. So let's exit out of this and go for 1,000. And oh, look at this, it's now less than 200, and if more people get infected, it's slowing down even further, and it's now below 50, it's now below 40, and now it's getting very, very slow. See how this is dropping further and further? Now it's around 20. And why is that? Why is our animation so slow for all of a sudden? Now, the reason for this, I'm not going to exit out of this before my little computer breaks down on me. The reason for this is that we have implemented the infection part in our animation in a very poor manner. And the reason for this is that we are running an extreme number of unnecessary checks. Now, when I say check, what do I mean? Well, down here, we're computing the distance between an infected person and a healthy person. And now we are checking whether that distance is less than 20. And computing this distance and then running this little check down here, that takes time, and this time adds up. Now, if there are, say, 1,000 people in our animation, and 10 of them have the virus, we are checking these 10 people each against all the other people. So essentially, if there's just 10 people and 1,000, we are running almost 10,000 many checks. And in a lot of cases, these checks are unnecessary because we are computing the distance between two people that are so far away that, of course, they are not going to be infecting each other. And this is something that we will have to take care of in the next video, and I'll be introducing what I think is a pretty neat solution to this problem. We want to have a large number of people, but we also want to have a smooth and quick animation. And right now, this is just not doing it, because if there's like 3, 4, 5, 6 people with the virus in the animation, the frame rate just drops and drops further and further, and we have to fix this, and we'll do this in the next part of the series. See you then.